Okay, so hello and welcome back. So the next question that we have here is another question that I don't know why this page is not scrolling down. Okay, so we have question number 6. And question number 6 is you want to find the mean and standard deviation using the shortcut method. So the mean and deviation. And you want to do it using the shortcut method. So the data that you have is basically something like this. So you have your x of i's, you have your f of i's, and then your data is basically 60 through 68. So you have 60, 61, 62, 63, 64, 65, 66, 67, and 68. And the frequency is 2, 1, 12, 29, 2, 1, 12, 29, 25, 12, 10, 25, 12, 10, 4 and 5. Okay, and you want to find the the mean and the standard deviation using the shortcut method. Now we use the shortcut method because using other methods for finding deviation is not easy. For example, supposing you want to find deviation, let me see. So this is mode, for example. The deviation, for example, is x sub I minus x bar, right? So for example, if you want to find variance, you have to use this formula sigma squared is equal to 1 over n sigma x. Well, there is an f of I here as well that I haven't written in my formulas. X sub I minus x bar whole squared as I goes from 1 to n. And of course, when you want to, this is variance, and standard deviation would be when you take the square root of this whole thing. So if you take the square root of variance, you'll get standard deviation. Now over here, what you need to do is you need to subtract x of bar from your basically from each observation, and then then raise that to the second power, multiply f of I into that whole thing, and then take the sigma of that, divide the whole thing by n. Now over here you need to calculate x of bar. Now to calculate x of bar here, which is the mean of all of this data, you need to, for example, you can do it either using the direct method, using, for example, 1 over sigma f of I x sub I over, for example, sigma f of I. Or you can do it using the assumed mean method, which would be, for example, x is equal to, for example, a plus sigma f of I d of I over sigma f of I. Here you calculate basically, here you use the assumed mean of the data, or you can use step deviation, which would be x bar is equal to basically a plus sigma f of I u of I, for example, divided by sigma f of I and you have to multiply the whole thing by the class size of your class, the class size of your classes. Now, the shortcut method that we introduced is actually a variation of this method over here, because you take the assumed mean of the data, we called it capital A, and we also take the class size, and then we divided, we basically made some changes to x of I based on these two variables, and then based on that, we defined some other variable, for example, y of I, and then we use that in calculation, meaning that, for example, in using y of I, we said that then basically x bar was equal to, for example, a plus h y bar, for example. And then instead of writing sigma squared as this formula, we came up with another formula for variance, which was sigma of the variable x, or the standard deviation of the variable x. We found that as h divided by n times the square root of, for example, n times sigma of f of I y of I squared minus basically minus sigma of f of I y of I, as I goes from 1 to n, for example, and the same thing here, I goes from 1 to n, and you square this, and then take the square root of this whole thing, and that becomes the standard deviation of the variable x in terms of y of I. And of course, using this method, everything becomes simpler. The calculations become simpler because you make some changes to x of I becomes very smaller. So you make some changes to x of I becomes very smaller, and then we call it y of I, and then y of I comes over here, and you do all kinds of things with y of I. So it's basically the same thing that we did over here, meaning that if you put together the methods that we had before, it's essentially the same thing. But then, meaning that, for example, if you calculate your x bar using, for example, this method here, which is the method that we had before, or for example, this method here, both of which are usually easy to work with, then you can calculate your variance using this, and this would not be that hard to do, right? Now, but just to make sure that we understand that the shortcut method, which is not very essentially, I don't mean to say the word essential, which is not very necessary to know, because it's basically the same thing, and it would be basically just learning some new forms of the formulas that we already had, which you will forget eventually, right? I talked about this, for example, a couple of days ago, and now I have forgotten all of the formulas that I derived myself. And I'm sure that I'm not going to know any of those formulas after 2 weeks or so. But these formulas, for example, this x bar or this x bar or this sigma squared, is going to most probably stay with you, because there is a concept behind that, and the concept will not leave you. Okay, so now let's go over the shortcut method to see how the formulas work, and then we will use it once for this exercise. So basically, we said that if your x of i's are too large, what you can do, basically we said that we could take some value, for example this 64 or some other value of your x of I as the assumed mean, and I call it A, for example, as the assumed mean of your data. The assumed mean of the data. And then we have seen that even when you subtract your assumed mean from your x of I, your x of I is still a little bit too large, meaning that of course in this data that sort of thing we cannot see, but usually, for example, in cases where you have for example some classes over here and some f of i's related to those classes, then this goes from, for example, x1 to x2, this goes from x2 to x3, this goes from x3 to x4, and so on and so forth. So what that means is that, and usually the size of these classes is the same, meaning that x2 minus x1 is equal to x3 minus x2 is equal to x4 minus x3, and so on and so forth, and that is equal to h, which we call the class size. So your h is, we can take the h as the class size, and basically, so I can take my x of I, subtract a from it to make it smaller, and then scale it down by basically by dividing it by h, meaning that, or multiplying it by 1 by h. So this becomes the changed version of x of I. So once I have changed my x of I can call it, for example, y of I. I can define some other variable, for example, instead of x of I can write y of I, and now basically y of I is a function of x of I, meaning that when you change x of I, y of I will be changed. And also you know that basically from previously we knew that, from before we know that x bar is nothing but sigma x of I times f of I over sigma f of I, which you can call n, of course. So that is basically the frequency, the sum of the frequencies of the data. And over here, as I goes from 1 to n, right? So if I make some changes to rearrange this formula, I will get basically h times y of I is equal to x of I minus a, or I can say that x of I is equal to h times y of I plus a. So this becomes my x of I in terms of y of I. And so what I can do is that now I can calculate x bar in terms of not x of y but y of I, meaning that I can write x bar is equal to basically sigma, I can write it as sigma I goes from 1 to n, and f of I times x of I. X of I is basically this expression over here, which is h times y of I plus a, and I can divide that by n. And we have to do some algebra here. meaning that I can write this as 1 divided by n, for example, for this n, and then I can write this as sigma, multiply this in, meaning that sigma f of I, for example, times hy of I as I goes from 1 to n, and this is multiplied by the whole thing, plus sigma of f of I times a, f of I times a as I goes from 1 to n. So that is that. Okay, so now what we have here is basically this expression, and this expression you can see that basically the terms in sigma, basically in front of the sigma, whatever doesn't depend on I, because your index here is I, your I changes from 1 to n. Whatever doesn't depend on sigma, of course you can take out, you can treat it as because it doesn't matter. For example, what that means is that, for example, when you write sigma f of I times h times y of I as I goes from 1 to n, so what that means is that you have I starts from 1, so you have f of 1 h times y of 1, and then you have to add to that the next term, which is f of 2 times h times y of 2, then the next term, for example, f of 3 h times y of 3, and you need to go all the way up to when I is equal to n, where your term becomes f of n h times y of n. So you can see that h is basically common in all of these terms. So I can write this as h times f of 1 y of 1 plus f of 2 y of 2 plus f of 3 y of 3 y of 3 plus all the way up to f of n y of n. And this expression I can write it as h times sigma. I can write it as h times sigma. Write this properly. I can write this as h times sigma f of I y of I as I goes from 1 to n, which is equal to this expression, sigma f of I h times y of I as I goes from 1 to n. So you can see that this term that doesn't depend on I, you can just take it out and your expression becomes like this. So what that means is that I can take basically, for example, this h out, or this a, I can take it out. So I can write it as 1 over n, and over here I can write h times sigma, for example, f of I y of I as I goes from 1 to n, plus, for example, a times sigma f of I as I goes from 1 to n. And that is that. Now you know that sigma f of I as I goes from 1 to n, that is equal to n. That is equal to n. That is the total number of all of your, basically the total number of observations, which is basically all the frequencies added together. So this is equal to n. And you know that sigma f of I y of I as I goes from 1 to n is the same thing as sigma f of x. Sigma f of I, like x of I, for example, as I goes from 1 to n. That is there you have this thing, and then if you divide that by n, that is basically x bar. So that means that if I multiply these two together, I'll get h times x bar. h times x bar. Of course, since the variable is y, so then I get h times y bar. And then over here I have n. And since I multiply n by n, so if over here I will get a 1. So that means that basically x bar is equal to, and of course I have a over here, so a is multiplied here, so that means that x bar is equal to h times y bar plus a. So that is the relationship between x bar and y bar. So that's one thing. And then the next thing that we need to do is find variance or standard deviation. And we know that basically the variance of variable x is denoted by sigma of x whole squared. That is variance of the variable x. If you want to calculate, for example, the variance of variable y, that would be sigma of y squared. That would be the variance of variable y, for example. Now, since here basically we have both the variables x and y, so we have to basically make sure that what we write, basically we have to make sure that basically what we write makes sense in this situation, meaning that if I simply write, for example, sigma squared, you don't know whether you mean basically the variance of variable x or y, right? So now I know that the variance of the variable x, which is sigma of x whole squared, is we calculated this as 1 over n sigma of f of I times x of I minus x bar whole squared, as I goes from 1 to n. That we calculated. So since I know since now I have my x bar in terms of y bar, I can write this as 1 over n sigma of f of I times basically x of I, and x of I also have it in terms of y of y. I know that my x of I is h times y of I plus a. H times y of I plus a. H times y of I plus a. And x bar is basically this expression over here. You need to multiply this negative sign by both these terms. So that's negative hy bar minus a, which is, you can cancel these two out, and then you will get h times y of I minus y bar. That is h times y of I minus y bar. So you can write this as 1 over n sigma of f of I times h times y of I minus y bar. And then you can take this h out, so you can write this as h divided by n. H divided by n sigma of f of I times y of I minus y bar. And then you can basically, and this is I goes from 1 to n, of course. And so if I do this, simplify this a little bit, I will get of course there is a whole squared all around the place over here, so you have f of I minus times y of I minus y bar, and of course this is the h was inside this thing, so that's also h squared, right? So I forgot that part. So what that means is that now this is h squared over n, and sigma f of I times y of I minus y bar whole squared as y goes as y goes from 1 to n. Now this is exactly so over here when we wanted to define the variance of the variable x, we said 1 over n sigma of f of I times x of I minus x bar whole squared as I goes from 1 to n. Over here, this part is sigma f of I, y of I minus y bar, here is x of I minus x bar whole squared as I goes from 1 to n. I goes from 1 to n. That means that this is the variance, of the variable y, which you can call basically sigma of y squared, and that is sigma of x squared. That means I can write sigma of x squared is equal to h squared over n times sigma of y squared. And if I take, and there has to be of course you have to divide by n as well, so this n actually cancels out here, because over here you see the variance of the variable x, there is this 1 over n here as well, so this 1 over n would be a part of this expression here. So then this expression has to be actually h squared times basically sigma y squared. That means that you can say that the variance of the variable x is the same thing as h squared times the variance of the variable y. And then if I take square roots of both sides of this equation, I get the variance of the variable x is equal to h times the variance of the variable y. And so and basically you know that the variance of the variable y, I'm sorry, this is not the variance, this is the standard deviation. So you know that standard deviation, you know that the variance of the variable y, for example, the variance of the variable x, for example, would be this thing over here. I'll do it using orange color so you can see what I mean. So this would be the variance of the variable x. Now if I take the square root of this expression so that it becomes standard deviation, and change the variable so that the variable is y here, I would get basically sigma of y is equal to basically sigma of y. Let's see. Okay, so now there is a couple more things that we need to do here. Actually, I don't like to go through this algebra one more time, but it's now that we have come so far, let's take it to the let's finish it. So now the variance of the standard deviation of the variable x is h times the standard deviation of variable y, right? So let me find some more space here. So we said that the standard deviation of the variable, the standard deviation of the variable x is equal to h times the standard deviation of the standard deviation of variable y. Now we know that the standard deviation of variable y is nothing but basically the square root of 1 over n sigma of f of I times times y of I minus y bar all squared as I goes from 1 to n. That is the standard deviation of variable y. Now if I multiply h by this, so h times this would be h times this, which is basically essentially this expression over here, which you can write as the standard deviation of variable x, right? So what that means is that now I can what I can do is that I can make some changes to this, meaning that only this part, the square root of 1 over n times the sigma of f of I times y of I minus y bar all squared as I goes from 1 to n. Only this part, what I can do with this, I think we have somewhere done this probably, I'm not sure, but let's see. Or probably in the same basic derivation. So I can write this as the square root of basically 1 over n, and this 1 over n is multiplied by sigma of f of I times this thing, so I can separate my sigma. So I can write this as sigma of f of I y of I, and of course this is whole squared, so I need to first square this thing. So if I were to square this thing, I would write it as sigma of f of I, and this would be y of I squared minus y bar squared. We had this somewhere, I suppose. So we have y of I squared plus y bar squared. That's not y raised to power negative 2, but this is y bar squared minus 2 times y of I times y bar. That is that. Right? Now, and that's basically this whole thing raised to the second power, and I goes from 1 to n in all of these expressions. Remember that, please. Now I can write this as the square root of 1 over n times the sigma of basically f of I y of I squared plus sigma of f of I times y bar squared times y bar squared minus basically y bar I can take it out, y bar squared I can take it out, so I can write this as y bar squared times, for example, y bar squared times sigma of f of I, and then over here I can write negative 2y bar times sigma of y of I, and that's it. And 1 over n is multiplied by this whole thing, and this is a square root function that goes here. Now you know that basically sigma of f of I y of I squared, you cannot do anything there. You can sigma of f of I as I goes from I goes from 1 to n, that is equal to n. That is equal to n. So I can write, instead of this, I can simply write n. And sigma of y of I as I goes from 1 to n, that is just, and if I divide that by n, of course f of I is supposed to be multiplied here as well, so that is going to be y bar, right? You see over here, if I write sigma f of I y of I, and then if or let me write another step, that way we would just simply confuse ourselves. So let's not do that. So the only basically the only change that I made here is that I had forgotten to write f of I here, which I wrote here. Now what you can do is that you can write the square root of basically I can basically multiply these basically, which I can write 1 over n, for example, sigma of f of I y of I squared plus 1 over n y bar squared times sigma of f of I. And then over here I can write negative 2 times y bar divided by n, and over here I have sigma of f of I y of I, and that's basically that. Now over here what I have is basically sigma. I cannot do anything here, I just have to keep it as it is. And then over here I have sigma of f of I as I goes from 1 to n. This part is equal to n, and this n and this n will cancel out. Sigma of f of I y of I divided by n is equal to y bar. So these two parts is equal to y bar, and y bar times y bar is equal to y bar squared. So what you have is the square root of 1 over n sigma of f of I y of I squared plus basically we have the only thing that we have here is y bar squared minus 2 times y bar squared, right? And that is the same thing as basically the square root of 1 over n sigma of f of I y of I squared. Now that is minus y bar squared. Now y bar squared is the same thing as, I suppose, y bar is the same thing as, you can write it as basically x bar, you can write it as sigma, f of I x of I over n, for example, over n. So y bar, you can write it as sigma f of I x y of I over n. So I can write this as that, meaning that I can write over here the square root of 1 over n sigma of f of I y of I squared minus this thing over here minus sigma of f of I y of I over n whole squared take the square root of that, and over here I can take so as you know, basically if I raise this n in the denominator to the second power, I will get, and of course this n, this sigma basically only is related to the numerator. So over here I have n squared, so meaning that I can simply write this expression over here as sigma f of I y of I whole squared over n squared, and I have a 1 over n over here. So I can take a 1 over n squared out of these two expressions and write this as basically the square root of 1 over n squared times basically, now if I take a 1 over n squared, I'll have an n over here. N over n squared is 1 over n. And then sigma f of I y of I squared. And again, and this is already n squared, so I would be left with negative sigma of f of I y of I squared, right? And now if I take, now I have this 1 over n squared under the square root function. I can take it out, becomes 1 over n, the square root of n times sigma f of I y of I squared minus sigma of f of I y of I, and not y2 but y of I whole squared, and that is basically that. So now this part is basically nothing but this part over here, and we said that, let me make a screenshot here. So this part, the part that we calculated, was only this part over here. So if I multiply h by that, I will get the standard deviation as a variable x. So I can then write the standard deviation of variable x. The standard deviation of variable x is equal to h. I have to multiply h by that, so that becomes h over n. H over n, the square root of n times sigma f of I y of I squared, as I goes from 1 to n, minus sigma f of I y of I whole squared, and that is the standard deviation of variable x in terms of y of I, basically. So that is the standard deviation of variable x. Now let's use this formula, basically all of these formulas, to see what we can do with them, right? So now to sum this up, what we can say about this is that basically you can say that x of I is equal to a plus h times y of I, a being the assumed mean, and h being the class size. And then we have x bar we calculated as a plus h times y bar, and then the variance, or you can say the standard deviation, and the standard deviation of variable x we calculated as h over n, the square root of n times the square root of, I might have written this wrong over there. There is an n over here, of course. The sigma of f of I y of I squared, as I goes from 1 to n, minus the sigma of f of I y of I whole squared, and you take the square root of this whole thing, and that is basically the standard deviation of variable x. So now I can make a screenshot of this, and we will go and solve the problem. Okay. Okay, let's statistics formula, call it, for example, shortcut, and this got and save it. That's it. Okay, so now let's go and solve the problem. Okay, so now let's go and do example number 6, which is about the shortcut method. I mean, we need to use the shortcut method in order to use standard deviation and mean of some data. So basically the data that I have is like this. So I have my x of i's and f of i's over here. I have my x of i's and f of i's over here, and I have 60 through 68. I have 60, 61, 62, 63, 64, 65, 66, 67, and 68. And the frequencies related to those are 2, 1, 12, 29, 2, 1, 12, 29, 25, 12, 25, 12, 10, 4, and 5. 10, 4, and 5. So basically the mean and the standard deviation, based on the formulas that we found, were basically this picture here. Okay, so based on the data that we found, the mean and the standard deviation were these, basically. Where basically we said that x bar, we found that to be basically a plus h times y bar, a plus h times y bar, and so let's do this first. So and y bar is equal to so in order to calculate y bar, you need to have y of I, and y of I, right? So we said that y of I, we define that to be x of I minus a divided by h. So that was y of I. Now what I can do in order to calculate this is I take my x of i's, subtract the assumed mean of the data. For example, I take 64 as the assumed mean of the data. And then since I have no class size, you see I have no class size here because I have no classes, and moreover there is no number by which all of these numbers x of I minus a, all of these numbers, for example 60 minus 64 would be negative 4, 61 minus 64 that would be negative 3, 62 minus 64 that would be negative 2. There is no such number except for 1 on which all of these numbers would be divisible. So what I'm going to do is just simply take my h as 1. I'm going to take my h as 1 and take a as 64. And so then y of I would be equal to basically x of I minus a divided by h. So I calculate y of I for each x of I here, which would be, for example, 60 minus 64 divided by 1, which is just 60 minus 64, that's negative 4. For example, 61 minus 64, that would be negative 3, 6, negative 2, negative 1, and 0, 1, 2, 3, and 4. Now that I have my y of I can calculate y bar. So y bar is nothing but basically sigma f of I y of I divided by sigma f of I as I goes from 1 to n, and here I goes from 1 to n. So sigma f of I y of I is basically, I need to calculate that as well. So f of I y of I is equal to, for example, 2 times negative 4 is negative 8, negative 3, negative 24, negative 29, 0, 12, 20, 12, and 20. And sigma f of I y of I would be, sigma f of I y of I would be, that's negative 11, so that's an 11 or negative, of course, 24 and 29, 24 and 29, 10, 14, 1, that's 2, 4, and 6. Negative 64 we have as the negative numbers. And that's 24, 64, 84. So 84 minus 64 is equal to 20. So sigma f of y of I is equal to 20. And sigma f of I as I goes from 1 to n is equal to basically 3, 15, and here you have a 30, let's say 45, 44, 64, 69, 79, 79, 81, 91, 91 plus 10 is 101, so that's 100. That's 100. And so what I can do is now calculate my y bar. So this is equal to basically 20 divided by 100, which is 2 divided by 10, which is 1/5, which is 0.2, right? Now y basically, so x bar is equal to a, which is 64, plus h times, h we took it as 1, and y bar is 1/5, which is 0.2, I suppose. 1 divided by 5, you need to know these numbers, and there is a video on the internet. The video is in German. I will try to find, get the material and explain everything in English so that you know all of these numbers, like for example what is 1/5, what is 2/5, what is 3/5, and what is 1/7, what is 1/8, and all such numbers that you basically need while you're calculating something. That we will do later. So now 1/5 is what is 0.2. So there you have basically y bar is 0.2, so that's 64.2. 64.2. Now first of all, let's see if the answer over here is correct, and then 15.2, number 6. Well, they have taken this as 64. What I've gotten here is 64.2, right? Now let me actually find the mean of these numbers, just simply using the calculator. So I have 60 through 68. What is 60 through 68? If you have 60, 61, 62 through 68, so 60 through 68 is basically, of course, 1, 2, 3, 4, 5, 6, 7, 8, and 9 numbers. So the number of these numbers is 9. So the number is 9, and if you take this as your A, and if you take your D as 1, the common difference as 1, then S of basically 9, or let me write the formula for you. Basically, the formula for an arithmetic progression is S of n is equal to n divided by 2 times 2a plus n minus 1 times d. So you have n divided by 2, which is 9 divided by 2 times 120 plus n minus 1, which is 8 times 1, which is 8. So that's 128. That's 9 times 128 divided by 2. That's 64. And 64 times 9 is the same thing as 640. Meaning that 64 times 10 minus 1 times 64, which is 64. Do this calculation, you get basically a 5, 14, 13, and 10. That's a 6. 9 plus 6 is, 13. 9 plus 6 is equal to 15. 7, 8 plus 6 is equal to 14. 7 plus 6 is equal to 13, and that's a 5, 576. So the sum of these numbers is 576. S of n is equal to 576. And divide by 8. And if you divide that by 8, you will get the mean of all of these numbers. So 576, divide that by 8, you will get 7 times 8 is equal to 56. If I'm not mistaken, sometimes I make mistakes with 7 and 8. 7 times 8 is equal to 56. And you have basically 16. 2 times 16 is equal to 2 times 8 is equal to 16. That's 72. No, something is wrong. Let me actually add the numbers together. So you have 60 plus 61 plus 62 plus 63 plus 64 plus 65 plus 66 plus 67 plus 68. That is equal to 576. 576. And you have 1, 2, 3, 4, 5, 6, 7, 8. Now, oh, I'm sorry, divide by 9. 576 divided by 9 is 64. Now, this method has given me 64.2. How I made any mistakes here? So let's see, because I had this problem the previous time I solved this problem. I want to know if I'm making mistakes in calculation or am I making some sort of logical mistake. So x of I, basically we said that to calculate y of I, I'm basically subtracting each, subtracting the assumed mean from each x of I. That means that y of I is basically the same thing as d of I, for example, as we had in the assumed mean method. So for example, over here I have 60 minus 64 is equal to negative 4. 61 minus 60, negative 3. Negative 2, negative 1, 0, 1, 2, 3, and 4. And then f of I times y of I is 2, that's negative 8, negative 3, negative 24, negative 29, 0, 12, 20, 12, and 20. And the sum of these numbers is what? The sum of these numbers is basically 20 plus 12 plus 20 plus 12 minus 29 minus 24 minus 3 minus 8 is equal to 0. That's supposed to be equal to 0. 20 plus 12 plus 20 plus 12 minus 29 minus 24 minus 3 minus 8, that is supposed to be equal to 0. This is 0. I've made a mistake here. This is a mistake. So if this is equal to 0, then sigma alpha by y of I is equal to 0, and my y bar becomes 0. So that means that basically this whole thing becomes 0 divided by, and let me check sigma alpha y as well. Let me check sigma alpha y as well. Alpha y is basically 3 plus 12 plus 29 plus 25 plus 22 plus 9 is equal to 100. That is correct. Okay, so that is 0, and so that means that then a plus h times y bar would be basically 0, and then here you would have a 64. So your x bar is equal to actually 64, not 64.2. So your x bar is equal to 64. So now I can erase all of this, and then we can do the rest of the calculation. So that's one basic, that's a good thing that I know where the problem was, because the previous time, of course, that time I had multiple problems. I didn't really understand the procedure related to the shortcut method, and I had to read that a couple of times to understand it. And then I suppose I had some mistakes in calculation as well. So it takes me probably a couple of hours to get over this problem. But well, sometimes you need to have patience, because these concepts, some of them, it takes time for these concepts to sink in. Now the rest of this exercise we will do in the next video. See you in the next video.